All right, time to do some practice with limits that involve infinity, which also means when we're talking about horizontal and vertical asymptotes. Now, as always, to get the best result, you should try to do these problems by yourself before seeing those solutions. And make frequent use of that pause button. So only see a solution once you've really tried or you've made almost progress, but you're stuck and you really, really want to be stuck. And then you want to be unstuck. The more you can do by yourself, the better you're going to become. And you're great. And we want you to be even better. All right, so let's get into it. So our first problem, that looks pretty good. There's two limits here. So we get to do a problem twice. Now the difference between these two limits is one of them has a plus infinity, one of them is a minus infinity. But it's the same function. 7e to the x plus 3 over 1 plus e to the x. Okay, so we can pick. Well, we might as well just go in the order they gave it to us. So limit as x goes to infinity, 7e to the x plus 3 over 1 plus e to the x. Now the first thing we ask ourselves is, what is this doing? In other words, what's the behavior? And do we need to do more work? We don't jump in to do more work just because we want to do more work. Of course, we always enjoy the opportunity, but we want to do it with purpose. So let's think about what's happening here. We should think about the e to the x function. So e to the x looks something like that. And it's good to know these. It's good to have a collection of basic functions in their shape. So as you head towards negative infinity, it gets small. As you head towards positive infinity, it's getting big. Now we're in the head towards positive infinity side here. So e to the x is going to get big. So that says I have huge number times 7 plus 3. Honestly, the plus 3 is inconsequential. And so, what can we say? Well, the top is going to get big. Same thing with the bottom. E to the x is getting big. That plus 1 is inconsequential. All right, so we're going to get big over big, infinity over infinity. Now we see, yes, it's a true thing. This will require us to do more work. All right, well, what's the more work? Now, when we're going to infinity over infinity, the basic idea is to ask ourselves, what's causing us to get to infinity over infinity? In other words, something is big here. What's the big thing? And most importantly, what is the big thing? You might have several pieces and well, this piece goes to infinity, but this piece goes to really big. What's the piece that's really getting huge? And we can spot it. It's actually pretty easy to see because there's only, you got a 50-50 chance. It's these e to the x's. That's what's driving our growth towards getting big. It's what's causing us to head off to infinity. So if that's what's causing us to head to infinity, we're going to say, all right, let's slow it down and let's cancel out that growth. So what we'll do is we'll say, all right, we'll take our limit as x goes to infinity. We'll have 7 e to the x plus 3 over 1 plus e to the x, right? I've just taken our limit. And now the e to the x is causing our blow up, so I'm going to divide out by e to the x in both top and bottom. Because I'm doing it both on the top and on the bottom, the net effect is I'm not changing anything. I'm multiplying by 1. And again, we can multiply by 1 as much as we want. Generally, we like to choose a well-chosen one. So this becomes the limit. As x goes to infinity, we can multiply through. Notice the e to the x's cancel. Not a coincidence. We chose them to cancel. We want to cancel out the part that's growing. So we'll have 7 plus 3 over e to the x. Downstairs, we're going to get 1 over e to the x plus 1. Now, what's happening? Well, we still have e to the x's, but the way that they're there is much nicer. You see, we're dividing now by e to the x. So we're dividing by a big number. What does that say? Well, it tells us that these pieces here are going to get small. So 3 over e to the x is going to go towards 0. 1 over e to the x is also going to go towards 0. So now our limit's perfectly fine. We end up with 7 plus 0 over 0 plus 1 as we let x go to infinity, also known as 7. All right, good. Well, halfway done. What's the other half? Might take us a while. Let's see. We're going to take a limit as x goes to infinity of 7 e to the x plus 3. Oops, sorry. X is going to negative infinity. I can read. All right, 1 plus e to the x. Now, what happens? Before we divide out by growth, we always want to ask ourselves the question, what happens? Do we need to do anything? Well, x is going towards negative infinity. Now, as I come to negative infinity with the e to the x, what's happening to that function? It's getting small. It's going towards 0. So, that e to the x goes to 0, that e to the x goes to 0. And so it's just 0 plus 3 over 1 plus 0. Nothing strange happens. So the answer is 3. Okay, good. Nice, actually. Nice. All right, well, let's try another one. All right, so that was division. Let's do subtraction. Okay. Find the limit as x goes to infinity, square root of x squared plus 4x plus 7 minus x, and the limit as x goes to negative infinity, square root of x squared plus 4x plus 7 minus x. So again, similar expressions. The only difference is one is going to positive infinity, one is going to negative infinity. All right. Well, let's take a look. So we look at this and we say, let's start with the positive infinity. Why not? So what do we see? Well, we see the square root of x squared plus 4x plus 7, and here minus x. Now, if we just do a quick, I want to say back of the envelope computation, but really we're just going to look at it for a second and think about what's happening. Now x is going to infinity, which means that this x is going towards infinity. So that heads towards minus infinity. How about the first term? Well, the way we would parse it is to say, well, let's think about what's growing. The x squared, the 4x, and 7. Well, the x squared is going to get bigger faster than the 4x and the 7. So really it's behaving like the square root of x squared, which is like x. And that's going to infinity. So it's infinity minus infinity, which, no surprise, more work. Aha, who would have guessed? All right, good. So we're going to do some more work here. So now we say, all right, well, how do we handle this? Well, the good news is we have an approach. If we can get it to infinity over infinity, we can divide out by growth. So we have to somehow rewrite it so that it becomes something over something. This is where the conjugate comes in really handy. So you might also say, oh, conjugate would be helpful too because it gets rid of the square root. It's a double blessing. We get a fraction and we get rid of a square root. What a great day. All right, so upstairs, square root of x squared plus 4x plus 7 plus x, and downstairs, because remember, we always have to end up with not changing the result. We're not changing our expression. We're just finding a different way to write it. It's the same, or if you like, it's an equivalent form. It's just written in a hopefully more convenient way. Square root of x squared plus 4x plus 7 plus x. Now, we carry this out. So this is the limit as x goes to infinity. The a squared, well, that would be x squared plus 4x plus 7 minus the b squared, so that's minus x squared, all over downstairs, well, the square root of x squared plus 4x plus 7 plus x. All right, well, clearly at least we can do one easy simplification, which is to knock out the x squareds. Now, we ask ourselves the question, what's happening? it shouldn't surprise us we're going to have a problem. Well, but let's actually check. Upstairs, we're plugging in infinity. We get 4 times infinity plus 7. Okay, big number. That's the key. It's big upstairs. Downstairs, you get essentially x. Here's another x. So again, it's getting big. All right, so it's big over big. It's infinity over infinity. So what do we do next? Well, the next thing to do is to ask ourselves the question, what's the growth? What's causing it to go towards infinity? Or if you like, instead of saying what's causing it to go towards infinity, what's the speed at which we're going towards infinity? If we knew what our speed was, we would know how much to slow down by. Just the right amount. Just the right amount. Well, I only need to look at either the upstairs or downstairs. And on the upstairs, it's pretty clear where I should be looking. You see, the x, that's what's causing it to go to infinity because everything else is just a number. So the rate of growth is essentially it's growing like x. So we're going to cancel out that growth, and the way we do it is we're going to multiply both top and bottom by 1 over x. Again, it's the same as multiplying by 1. So this becomes the limit as x goes towards infinity of 4 plus 7 over x upstairs. Now downstairs, I'm going to pause for a second here. The end is certainly okay. That's plus 1. I would like to put this 1 over x and somehow put it into the square root. So I've been kind of cheating a little bit. And you may have spotted my cheat. And it's an okay cheat. We haven't fibbed yet. So there's no fibbing going on. Okay. The question. I want to put this x and move it into a square root. Can I do it? Well, is it true that the square root of x squared equals x? And why not? Oh, you thought I was going to say, yes, it is true. No, it's not true. Okay, why is the square root of x squared not x? What's wrong with that statement? Now, here you have to be careful. You see, when you square something, it's always positive. And when we take the square root, and notice the square root, we mean the positive square root. So the net effect is we always end up with a positive number. It always has the same size, but we've lost any information about the sign. So it's actually the case that the square root of x squared is equal to the absolute value of x. So you want to be a little bit careful here, because sometimes they can do little tricks here to throw you off. We don't want to be thrown off. We're going to get all the little details right. So, does that affect us in our case? Well, the answer is it depends what's happening. Now, when I say it depends what's happening, what I mean is, do we know something about the value for x? Is it positive or negative? So let's think about where x is going. X is going towards positive infinity. So I should think of x as being a big positive number. And in that case, I'm okay with saying that this 1 over x is the same as the square root of x squared. I'm okay with that because I know it's positive. If I knew that it was negative, I'd have to introduce a sign to correct. So, okay, so that's our side note. Now let's get back to our main business. So I'm going to put this square root inside here. So it's like I have a big square root, and now it's like I divide each single one of these terms by x squared. X squared over x squared is 1. 4 over x squared is 4 over x. And 7 over x squared is 7 over x squared. All right, good. Now, we're ready to ask the question. We've done some modification. Essentially, one thing you can think about is by dividing out by this 1 over x, it's like you're canceling some infinities. Just like when we were doing limits before, and we were like, oh, we're canceling the zeros. So now it's time for us to pause and say, all right, let's do an update. Let's see where we're at right now. Well, the 7 over x, that's going to be small. So that's going to go to 0 because it's a number over a big value. Similar, 4 over x is going to be small. 7 over x squared is going to be small. Then everything else is okay because it's just numbers. Okay, so that's good. Now we're ready to say what our answer is. So we end up with upstairs 4 plus 0, downstairs the square root of 1 plus 0 plus 0 plus 1, which really is 1 plus 1 or 2. So our answer is 2. Good, good. We're halfway there. Remember the other half? Negative infinity. All right. Well, let's see where we're going to end up going as we go towards negative infinity. So the limit as x goes towards negative infinity of square root x squared plus 4x plus 7 minus x. So let's think about this. So x is a large negative number. So let's think about our pieces here. What can we say about the square root of x squared plus 4x plus 7? Well, again, the 4x plus 7 is really not very big compared to the x squared. So it looks like square root of x squared, which is absolute value of x. So for large x, it's approximately absolute value of x. Now, x is going towards negative infinity, which says that this part is going towards plus infinity. How about this minus x? Well, if x is going towards negative infinity, minus x is going to the opposite. So this is also going to go to plus infinity. So what we have is that the first piece is getting bigger and bigger and bigger. The second piece, and when I say bigger and bigger, positive, the second piece is also, if we account for this minus, getting another bigger and bigger positive value. So it's getting extra, extra big. And therefore, it's going to go towards infinity. So this is an example where in one direction we get huge, and in the other direction we converge. These things can happen. And so you got to check. Got to do the work. All right. Good. Well, let's try another one. Find the limit as we go to infinity of x sine of 1 over x. Now, okay, this is slightly different. Now let's actually just think about what's going on here. So, well, what do we have? The x, well, x is going to infinity. So that's getting big. All right. How about 1 over x? 1 over x is going to get closer to 0, which means small. And then sine of small, well, that's going to go to 0. So it's going to infinity times 0. And you're like, oh, well, what is infinity times 0? Well, you might be tempted. Maybe it's 0. Not always. Maybe it's 1. They cancel out just right. Maybe. Infinity? No. The right answer, of course, is more work. More work. This is another example of what's called indeterminate forms. It's essentially, it really means ambiguous in that it could be anything. The reason we say it could be anything is the part that's causing it to be 0 might just balance out in the right way with the part that's causing it to be infinity so that we get a number that's nice. So we don't know until we check. So we're going to check. Now, one of the things that this reminds us of is we see a sign and we see a polynomial thing in front and we're like, oh, hey, there's that basic fact about the sine function. Namely, the limit as something goes to 0, sine of something divided by something is going to be 1. So as long as what's underneath matches what's on the inside, so in other words, downstairs matches what's inside the sine function, and that thing is going to 0, then the result goes to 1. All right, so what can we do? Well, we can say the limit as x goes to infinity of x sine 1 over x, what we'll do is we'll take this x and we'll move it downstairs. Now, how do you move it downstairs? If you're moving something from the upstairs to the downstairs, you flip it over. You take the reciprocal. So this is the same as the limit as x goes to infinity of sine of 1 over x divided by 1 over x. Now you might say, it's the sine of blah over blah, but wait a second, x is going to infinity. Gotta be careful here. Remember, what's our blah? Oh man, this is great. I feel like we should come up with new mathematical notation that stands for blah. So it's not, the key is not what's happening with x, the key is happening with 1 over x, right? 1 over x is what's on the inside. That's the question we need to be asking ourselves. So one of the things we can do is we can say, all right, let's just change names. Now the ability to change names, this is actually a really important skill in math. And if you can get comfortable with this skill, it'll help you out tremendously. So you should start thinking about this. Well, for example, suppose instead of calling it 1 over x, I'll call theta 1 over x. So what do we have? Well, there's a limit. We'll come back to what theta is doing. Then we have sine of theta over theta. Now the question. We know that x is going to infinity. So the question is, what is 1 over x doing? So as x goes to infinity, what does 1 over x do? It gets smaller and smaller. It goes to 0. In fact, we can be more precise and say it goes to 0 from above. So now in this format we say, aha, now we see what's happening. Sine theta over theta, that's something we recognize. That goes to 1 because we're going to 0. It doesn't matter that we're coming from above because it's true coming from both directions. That goes to 1. And that's our answer. So it is possible to get something infinitely large times something getting arbitrarily small and have them balance out just enough that we get a value, which is why we always like to do the work, because you never know. And then you do the work, and then you know. And that's good. Knowing is good. It's half the battle, as they say. All right. Let's do this problem. Multiple choice. Ooh, that's good. Of course, it's 6 choices. So I don't know if our odds are great. Well, that would be if we're guessing, but we're not going to guess. We're going to be smart about it. Given the limit as x goes to 0 of x times f of x equals 3, what can we conclude about the limit as x goes to 0 of f of x? And I should point out, 0 from below, 0 minus. So I'm coming from the left-hand side. Now there's a couple of different options here. So, well, we need to go to 3, so maybe it's the case that f of x goes to 3. Could be. Or maybe it goes to infinity. Well, that's a bold move. Or negative infinity. Maybe it doesn't converge. Or maybe we don't have enough information to make any conclusion about whether things converge or not. And of course, the last option, this situation can never happen. Let's see why this is an interesting question first off. Let's think about what's happening here. So if we're looking at the limit as x goes to 0 from below of x times f of x, we really have 2 pieces. We have the x and we have the f of x. Now the f of x we know very little about because all we know is it's f of x. The x, on the other hand, we do know how x behaves. This is going towards 0. So 0 times something is getting close to 3, right? So that's our thinking. It's like 0 times something is coming 3. Well, what does that tell us about the something? Well, it shouldn't be 3, right? Because 0 times 3 does not give 3. No. So we can really make that as an option. We just saw in the last problem that we had a case where 0 times something big was a number. So maybe this is huge. Okay, that's a reasonable guess. Okay, now, doesn't mean it's right, but it could be. But I think the situation can happen. So I'm going to rule this one out really quickly. All right, so how are we going to make progress? Because we haven't really eliminated very much. Here's what I like to do. when I'm looking at this, I like to ask the question, what's happening nearby? You see, when we talk about limits, what we're really saying is, lo and behold, whatever this part is, it has to be getting close to 3. So we can say near x equals 0, x f of x is very close to 3. Now, we really truly mean very close. It can be arbitrarily close to 3. All right, so how do we use that? Well, that says that f of x is approximately behaving like 3 over x. So if the limit is going to be 3, we need the function f of x to behave like 3 over x. See, that's why we can say that the situation can happen if f of x is 3 over x. Now, is that enough for us to figure it out? Well, actually, yeah, it is. Because I say, okay, if I need to know what f of x is doing, I can answer the question by saying, what is 3 over x doing? Because this is a good approximation. The whole idea is that as we move in, the approximation gets better. So, what's happening to 3 over x? Well, it's 3 over a tiny number. So it's behaving almost like 3 over 0. That means we're blowing up. But how? What's our sign? So now we pay attention. And here is where we say, aha, we know what our sign is because it's marked. That little minus there. That means that we're coming to 0 from below. So we're coming in from below 0. That means we're negative. So since we're negative, so what we have is we have 3, a positive number, divided by a very small, tiny negative number. So this is a large negative number. And moreover, it gets larger and larger as your x is going to get closer and closer. So what's going to be the behavior? It's going to blow up towards negative infinity. And that's the answer. That's the answer. Good. The idea of understanding what's happening nearby really does give us power. It's sort of saying, hey, if I know what my limit is, let me use the fact that it's a good approximation, and then I can get some information about the behavior. All right, good. Well,